This is block 8 from topic 8 on page 259. First thing we're going to look at is today's starting kind of inequalities and how they work. But lucky for us, inequalities work a lot like equations work. So there's not a whole lot of new things that we're learning for today. The only new thing we are learning is, one, we're refreshing our memory on graphing them inequalities. And then there's one little tricky thing that we have to do when solving inequalities. But other than that, there's nothing new that we're learning. So we have this example of a car rental company charging $29.95 to rent a car. So just to rent the car, it costs $29.95. Then it says plus 16 cents per mile. So every mile that I use that car, I have to pay 16 cents. My boss is very careful with the company's money and does not want me to spend more than $75 ever for my travel expenses. So I want to do what my boss wants me to do, right? So I don't want to get in trouble and get fired. So right now we have kind of a equation written of what it was set up here. I want to change that to more mathy way of seeing an equation. So I'm going to change that. I'm going to change the rental charge to an R, the plus to a plus sign. 16 cents, I'm going to change that to a decimal. Per mile is M. So what does M stand for?
Mile.
Mile. And why is it being multiplied to 16 cents? Because it's every mile, it's being multiplied by 16 cents. Okay, so this kind of answers our question number 1 in our book, so we can go ahead and jot that down. Whenever I was doing this problem, I wrote, before I looked at the answers, I wrote that. It was. Those on the video, I wrote R equals 0.16 M plus $29.95. Was I right or wrong when I wrote this?
Right.
Am I still right?
Yes.
Okay, basically, I rearranged everything properly. Is it okay to rearrange some things?
Yes.
If the teacher said, give me a problem, or not the teacher, I'm jumping ahead. Is 2 plus 2 the same thing as 4?
Yes.
So these two say the same thing, but they look different. Same thing here. So they are the same. This, however, is an equation, and I introduced this lesson saying we're dealing with inequalities. And that's wrong. Too much technology. So I need to look at this as, first I'm going to look at it as a graph and see how many miles I can go with $75. Because I'm going to reach a limit where I can't travel anymore or my boss is going to be mad at me, correct? So I'm going to graph several various miles. Looks like I counted by 50. Looking at various costs. So, if I went 100 miles, is my boss going to be mad at me? No, because my total is $45.95. Is that under $75?
Yes.
Okay. If I went 400 miles, is my boss going to be mad at me?
Yes.
Yes, because I went over. So looking at this table, it looks like I need to fall in between some amounts here. So I need to go between 250 and 300 miles. I just don't know what that is. Would you probably want to know the exact miles you could go so you don't get in trouble?
Yes.
I would. So what we're going to do here is change this equation to an inequality that says we cannot exceed $75. Notice how they look the same. That answers your question number 2 for writing a rule of an inequality. So this is your answer to number 2. Alright, so let's refresh our memory first on some inequality stuff. And inequality graphing in particular. So if I was to graph x is greater than 7, what numbers on this number line are greater than 7? 8, 9, and 10, but I would also say the arrow, because it keeps going on and on and on, right? So my question is, do you remember we're in block 8 today, back in block 1, you wrote a sticky note or you wrote it just in your workbook, I think on page 223, about open and closed circles of inequalities. Refresh your memory on that on page 223. You either had a sticky note or you wrote it on that blank page. Some people had sticky notes, some people have blank pages. So, it said, for it to be an open circle, what inequalities represent an open circle?
Greater than and less than.
Less than and greater than. What indicates a closed circle?
Less
Less
than
than or equal to
and
greater
greater
than.
than.
Okay, so a closed circle means it has to be equal to. What kind of makes sense? If I'm putting an open circle on a number on a graph, that's kind of like a hole in the graph. It can't be that number. If I put a closed circle, it's saying it's filled in. It can be that number. So when I'm looking at x is greater than 7, you already told me that 8, 9, and 10 are greater than. So is it going to be open or closed circle?
Open.
Open, because it doesn't have an equal to sign. Because can 7 be greater than 7?
No.
No, it's equal to. So that isn't true. So there's an open circle. Oh, forgot. Are all these values greater than 7?
Yes.
So they could all represent, even this one, even though it's extremely tiny, it's very, very, very close to being 7, but it is still greater than 7. So I could graph this with an open circle at 7, and I could shade it towards the greater than values. A little trick that I use is if the variable is on the left, it kind of points the direction you need to shade it. See the arrow pointing? The inequality? Who is the alligator eating in this problem here? X. is this problem different than that?
No.
7 less than x is not different than that, because who is the alligator eating here? But is my variable on the left side?
No.
No. So my trick is, if the variable is on the left side, then it's gonna tell me, it's gonna point to which way I need to shade. Just kind of a quicker way to know which way to shade. So we shaded to the right here. Let's look at some more. This is not in your book, you're just following along up here. We already wrote all of these on page 223 in your book. They're just going back through them. Although they are introducing one other. Have you seen not equal to symbol?
Yes.
Okay, we've seen that. Can a number not be equal to something?
Yes.
So that makes sense. So that's the symbol that they came up with. So we're going to graph another problem. This time we're going to graph x is less than 7. We'll notice that the variable is on the left. The variable is on the left, so the arrow is pointing to the direction that it should be shaded. Well, let's see if it's true. It says 0 is an answer. Is 0 less than 7?
Yes.
Yes. It says 10 is not an answer. Is 10 less than 7?
No.
So that's why it's not shaded. This is not shaded as well because there's a hole. Is 7 less than 7?
No.
No, so that's why there's a hole in the graph. Okay, looking at another one. This time we have x less than or equal to 7. What's going to be different with this graph?
It's gonna be shaded.
A shaded circle, shaded to the right or to the left?
To the left.
To the left, let's see. So, closed circle on 7, shaded to the left. Well, is 0 less than or equal to the 7?
Yes.
Yes.
That's why it's shaded. Is 10 less than or equal to 7?
No.
Is 7 less than or equal to 7?
Yes.
So that's why it's filled in this time. Okay, then I bet it is x is greater than or equal to 7. Closed circle, shaded to the right. Is my variable on the left?
Yes.
So it is pointing to the direction I need to shade, and that one makes sense. Two more actually. What about x equals 7? What would I put? Just a dot on 7. Then, what about x is not equal to 7? Anybody know how that graph would look? It'd be anything other than 7, but how would I show that on the graph?
Just color equal sign slash.
That's the symbol, yes. But how would the graph be shaded? Claire? All of them? Shaded on both sides, but what should I do to the 7?
Unshaded circle.
Open circle, because it would be a hole, and it kind of makes a funny looking graph, kind of weird looking. So there's a hole in the graph, and both sides are shaded. So anything but this little guy here makes that equation work. Well, is 0 not equal to 7? Is that true?
Yes.
Yeah. Is 7 not equal to 7?
No.
It's equal to, that's why it has an open hole there. It's kind of confusing sometimes. Alright, number 3 is supposed to be homework, but I kind of feel like working it with you.
I can do it all.
So, number 3, let's graph these for practice. So A, is that going to be an open or a closed circle? Open circle. Okay, I need values that's less than -4. So is that going to be to the right or to the left? Less than is going to be smaller than -4, and I like to bold my arrow so that I know it keeps going on and on. Then B, open or close circle.
Close.
Closed. I need numbers greater than 0, so is that to the right or to the left?
Right.
To the right of the point. I can test this. Is 5 greater than or equal to 0? Is that true or false? True. Is -5 greater than or equal to 0? True or false? False, that's why it's not shaded. Alright, C. X is not equal to 5. What do I need to do here?
Open circle.
Open circle on 5,
Color.
and then everything else, because it wants anything but 5. My scribble scrabble is a little messy looking. Hard to draw a straight line. D, X is greater than -7. Open or close?
Open.
Open. I need greater to than, so is it to the right or to the left?
Right.
Right is greater than. That makes sense, because I think 0 is greater than -7, right? So that's good, it's shaded. X is equal to -2.25. What kind of point am I going to put there? Open or close? Okay, well here's -2. Is it before -2 or after -2? It's a little after. Would you say open or close? Close. Any shading? No shading on that. F, X is less than or equal to 4 2/5. Open or close? Close. Here's 4. Is it before 4 or after 4? It's a little after 4. You said close, so close circle. Any shading?
Yes.
I need less than. So values less than that to the right or to the left? Left. And there we go. Alright, let's take a look at number 4. It says when you solve that inequality, 29.95 plus 16 cents M less than or equal to 75. That was the problem we got from that word problem a minute ago, right? What did 29.95 mean?
How much is
Cost per month.
the rent?
$29.95 is how much to rent the car. Then what did 16 or cents M stand for?
How many? 16 cents per mile.
16 cents per mile, because M stood for mile. Less than or equal to 75. What did 75 mean in the situation?
How much it costs?
How, the boss didn't want me to go over that amount, so that was pretty crucial amount I needed to remember. So it says, what question will you have answered about the car rental scenario if I was to solve that problem? So I'm just going to say, this is not the correct answer, but I'm just going to say I got the answer of M equal or is less than or equal to 275. What is that going to tell me about that situation of that problem? What did M stand for?
Miles.
Miles. Okay, so what is that telling me?
It's less than or equal to 275.
What is less than or equal to
The
275? The miles. So what happens if I travel 276 miles?
Same thing.
It'll be over.
Is my cost gonna be more or less than 75? It's gonna be more than $75. Am I gonna get in trouble?
Yeah.
Yes, okay, what happens if I go 270 miles?
That's good.
That's all right. It's gonna be below that cost. So this tells me, this is what you're gonna write, it tells me how many miles I can travel without going over my budget. What was my budget?
$75.
$75. So by solving that problem, I'll know exactly how many miles I could go without making my boss mad. Okay, let's practice a little more about, or investigate kind of, a little more on our inequalities. So number 5, they want us to put inequality symbols in these blanks. And they kind of have a pattern going. It looks like this column that they are adding some numbers. This column they are subtracting some numbers. So we're kind of looking for patterns. So 2 plus 1 is greater than or less than 8 plus 1.
Less than.
Less than, so I'm going to fill that in. 2 plus 2 and 8 plus 2, what would go here? Less than. 2 plus 3, 8 plus 3, less than. Let's look at subtracting the same numbers that we just used. 2 minus 1 and 8 minus 1, what would go here? Less than. 2 minus 2, 8 minus 2,
Less than.
less than. 2 minus 3, 8 minus 3,
Less than.
less than. Okay, so here I added 1 to both sides. Here I subtracted 1 to both sides. Did anything happen with this inequality symbol? Did anything change? It stayed the same. What about here? I added 2, here I subtracted 2. Anything change? Added 3, subtracted 3. Anything change? So 6 says what happens when you added every time. Did anything change?
No.
So we're going to say inequality stayed the same. So 7 says what happened when you subtracted. So here I subtracted 1 to both sides. Did it change from adding?
No.
Subtracted 2, did it change?
No.
Okay, so I'm going to say again, inequality stayed the same. Made an F, that's a 2. Okay, so we looked at adding and subtracting. What do you think we're going to look at next?
Multiplication.
Multiplying and dividing by different type numbers. So 2 is what with 8? What inequality?
Less than.
Less than. Okay, it looks like this column is multiplying by positive numbers. This column is multiplying by negative numbers. Dividing by positive, dividing by negative. So let's fill in with some inequality signs. 2 times 1 and 8 times 1. What would go here?
Less
Less
than.
than.
Less than. 2 times 2, 8 times 2.
Less than.
Less than. 2 times 3, 8 times 3.
Less than.
Alright. We're using the same numbers, but this time we have negatives involved. 2 times negative 1 is negative 2. 8 times negative 1 is
Negative
negative
8.
8. So I have a negative 2 and a negative 8. What symbol goes here?
Greater than.
Because negative 2 is larger than negative 8. Then I have 2 times negative 2, 8 times negative 2. What goes here?
Greater than.
Greater than. 2 times negative 3, 8 times negative 3.
Greater than.
Greater than. So from a positive 1 being used to a negative 1 being used, what happened?
Nothing. It switched.
It flipped,
Yes.
right? What about positive 2 to a negative 2? Flipped. Positive 3 to a negative 3. So it seems that it's flipping. Let's look at division. Positive, I have 2 divided by 1, 8 divided by 1. What goes here?
Less than.
Less than. 2 divided by 2, 8 divided by 2 is
Less than.
2 divided by 3, 8 divided by 3 is
Less
also less than. Now looking at the negatives. 2 divided by negative 1 is negative 2. 8 divided by negative 1 is negative 8. That's going to be a greater than. What about this next one?
Greater than.
Greater than, and then,
Greater than.
so from a positive to a negative, they ended up flipping as well for division, correct? So that brings us to our one trick that is the only difference with inequalities, is the symbols. Did anything flip with adding or subtracting?
No.
No, everything stayed the same. Anything flip with multiplying or dividing? Yes. When did it flip? Here it was a less than, which is the same as this, but when it was negative, it flipped from this, correct? So when you multiply or divide, this goes for number 9. Let me find it. For number 9, I would write this and put big stars because this is the only thing you have to remember with inequalities. And it is the number one thing that kids forget to do. You'll forget to do it come next year too. Multiplying and dividing by a negative flips the inequality. Does it flip it if you divide by a positive? No, just a negative. Add and subtracting anything, a positive or a negative, always stays the same. So we're writing that for number 9. Anyone still use this? Okay, let's look at number 10. Solve the inequality 8 minus 2x is greater than or less than 14. And it says by first subtracting 8 from both sides. So first, I'm just going to rewrite the problem so I can do some work with it. Notice how it looks a lot like an equation that we've been doing. The only difference is what?
The sign.
The sign. So I'm going to make my two different houses. It still looks like I have parents and kids and houses all the same. So, who is my kid here?
8.
8. Who's my parent?
2.
2 and X. Do they have parents have a positive or a negative attitude?
Negative.
Negative. Does the kids have a positive or a negative attitude?
Positive.
The sign in front is what goes with it. So there's no sign, so it's understood to be a positive 8. So it's positive attitude. There's a subtraction sign, which pretending to be a negative, so the 2 has a negative attitude. Okay? Who does Miss Adams say to move away first? The kids, which would be 8. And it's a positive 8. How would I move the 8 over?
Subtract 8.
Subtract 8 from both sides. Whoa, gosh, I didn't want to draw a line there. Notice how it said solve this by first subtracting 8. Did I subtract 8?
Yes.
Okay, so we're doing it like Miss Adams said to solve these problems. We got rid of the kids. Did I cross out this minus sign? No, that 2 still has that negative attitude. Lots of people forget to bring down the attitude with the person. Just because you walk out of my room doesn't mean you don't have the same attitude. Sometimes you do. Okay, then to continue solving this, I would have to divide, and who's getting kicked out? The 2. Does X want the negative attitude to stay in the house? He wants it to leave as well. So the negative attitude and 2 is leaving. A buzzer should be going off in your head since I'm solving inequalities and I said divide by a negative. What does my trick on number 9 say I have to do? Do what? It changes. The inequality sign has to be flipped. So I have to flip the inequality sign because I divided by a negative. This cancels out. 14 divided by negative 2 is
Negative 7.
negative 7. Is X by itself? Yes. OMG. I thought y'all kept waving at me for some reason. So let's back up. I kept seeing faces looking at me funny. Alright. 14 minus 8 is 6. Then we divide by negative 2. Sometimes I just get so excited and I forget. I have to flip my inequality sign. And then 6 divided by negative 2 is negative 3. And that looks more like my answer. So X has to be less than or equal to negative 3. It's not a question, it's just a statement. Okay, so here's where I want to lead the discussion. So listen carefully because this group is the one that's going to understand it the most here. Miss Adams said, I started this problem by saying Miss Adams said you have to move who first? Kids first. And notice the problem said first subtract 8. Do we all have to solve problems the same? No, we don't. I think it's easier and it helps kids in middle school solve problems by moving the kids over first. Doesn't always have to work like that. I could have moved the parents together, not split them up, but move them together over to the other side. Then I have a different problem that I can solve. That is helpful later on in your math career when you have larger problems to be moving people around like that. So that leads us to problem 11, which I'm going to start with tomorrow. So today we solved it moving the kids over first. Tomorrow we're going to move the parents over together, then split up the family. So let me close out my video. Thanks for listening. Have a great day. Like, subscribe, and hit the notification bell. And peace out, home dogs.